Welcome to another Databricks learning session. In this video, we're going to explore Databricks Metric View, one of the powerful capabilities that helps organizations standardize and govern business metrics across the data platform. This is part one of the series, where we'll cover the fundamentals and understand why metric views are becoming an important component of modern analytics architectures.
Have you heard about metric views in Databricks and wondered how they simplify business reporting and analytics? A metric view is a Unity catalog object that centralizes business metric definitions using a semantic layer approach. Unlike traditional views or materialized views that lock aggregations at creation time, metric views separate measure definitions from dimension groupings, allowing analysts to perform flexible analysis at query time. Key characteristics of metric views. First, metric views are defined using SQL DDL with a YAML body, currently supporting YAML version 1.1. They contain two core components: dimension.
Databricks Metric View Workflow. Introduction. How do you create, model, and consume a metric view in Databricks? Let's walk through the complete Unity Catalog metric view lifecycle, from source assets to business consumption. Step 1. Unity Catalog Asset. Everything starts with a Unity Catalog asset. A metric view can be built using multiple Unity Catalog objects, including Unity Catalog View, Unity Catalog Table, existing Unity Catalog metric views, Unity Catalog Foreign Table. These governed assets serve as the trusted foundation for business metrics. Step 2. Define. Once the source asset is identified, the next step is to define the metric view. The definition is created using YAML for semantic modeling and SQL for the metric view DDL. Step 4. Query and consume. Once the metric view is created, it can be queried and consumed in multiple ways. Code-based access. Developers and data engineers can access metric views using SQL, Python using SQL, Scala using SQL. Alerts. No-code access. Business users can consume the same metrics through AI/BI dashboards, AI/BI Genie, Alerts, Assistant. This enables both technical and non-technical users to work from the same trusted business definitions. Key takeaway. The Databricks Metric View workflow follows a simple yet powerful approach. Start with Unity Catalog assets, define metrics using YAML and SQL, model dimensions and measures in a Unity Catalog metric view, and then query those metrics through both code and no-code experiences. This creates a centralized semantic. We'll learn how to create a basic metric view in Databricks using SQL and YAML. Metric views use the syntax create view ... with metrics, language YAML as $$. This approach allows you to define business metrics, dimensions, and calculations in a centralized semantic layer. Let's walk through the process step by step. Step 1. Create the view. First, create or replace a metric view. The example creates a view named catalog.schema.salesMetrics using the with metrics clause and language YAML. We start by specifying version 1.1. Then the source dataset. The source query selects order ID, customer ID, order date, amount from catalog.schema.orders. We then add a comment describing the purpose of the metric view, core sales metrics for revenue analysis. Define dimensions. Next, we define the dimensions used for grouping and analysis. The first dimension is region, with the expression region and the comment sales region. The second groups data by month using date trunk _ month order date. The display name is order month with the comment month when order was placed. To improve discoverability, we can also define synonyms such as month, order time. These alternative names help users interact with metrics more naturally. Step 2. Define metrics. Now let's define the business measures. Metric 1, order count. The first metric is order count using count of 1, with the comment total number of orders. This provides a simple count of all orders in the dataset. Metric 2, total revenue. The second metric is sum of amount. We assign a display name total revenue and add the comment sum of all order amounts. We also apply formatting, type, currency, currency code, USD, decimal places, exact, places, 2. This ensures revenue values are displayed consistently across reports and dashboards. Metric 3, average order value. Calculated as sum of amount divided by count of 1, with the comment average revenue per order. This metric helps measure customer purchasing behavior and overall sales performance. What you get? By creating a metric view, you gain several powerful benefits. Standardized business metrics. Define metrics once and use them everywhere across your organization. Flexible analysis. Query the same metric across any dimension without redefining business logic. Accurate results. Ensure correct aggregations for complex measures and calculations. Ready for AI and BI. Power dashboards, analytics applications, and Gen AI experiences using trusted business metrics. Key takeaway. Databricks Metric Views enable you to define dimensions, measures, formatting, and business logic in a centralized semantic layer. Using SQL and YAML together, you can create reusable, governed metrics that deliver standardized business metrics, flexible analysis, accurate results, and AI/BI-ready insights across the enterprise. Define once, govern centrally, and analyze everywhere with Databricks Metric Views. Now that we've created a metric view, let's explore some practical ways to query it. In Databricks, metric views allow users to retrieve trusted business metrics using the measure function, ensuring consistent calculations across reports, dashboards, and analytics applications. Let's look at 5 common query patterns. Example 1. Simple aggregation by dimension. Our first example performs a simple aggregation by dimension. We select region, total revenue using the measure of total revenue function from the catalog.schema.salesmetrics metric view. Using group by all, Databricks automatically groups the results by the selected dimensions. Finally, the results are sorted by revenue in descending order. This query answers a common business question: which regions generate the highest revenue? Example 2. Time-based filtering. Next, let's analyze metrics over time. Here, we select order month using datetrunk.month order month, order count using measure of order count from the same sales metrics view. We then filter the data using year, order month equals 2026. This returns only records from the year 2026. The results are grouped and sorted by month in ascending order. This type of query is useful for tracking monthly sales trends and seasonality. Example 3. Getting totals without dimensions. Sometimes we need an overall KPI without any grouping. In this example, we select measure of total revenue as total revenue from the sales metrics view. Using group by all without dimensions returns a single aggregated result. This provides the total revenue across all regions, products, customers, and time periods. Perfect for executive summary reports and dashboard KPI cards. Example 4. Percentage of the total. A common business requirement is calculating each group's contribution to the total. In this query, we select region, revenue using measure of total revenue. Then we calculate revenue divided by the total revenue across all regions using a window function. The formula multiplies the result by 100 to produce a percentage value. The output shows revenue by region, percentage contribution of each region to overall revenue. This is extremely useful for market share analysis and performance comparisons. Example 5. Top K analysis with ranking. Finally, let's identify the top performing regions. We begin with a common table expression named ranked. Inside the query, we select region, revenue using measure of total revenue. Then we assign rankings using row number over order by measure of total revenue, descending. This ranks regions from highest revenue to lowest revenue. In the final query, we filter the results where rank is less than or equal to 5. The output returns the top 5 revenue-generating regions. This pattern is commonly used for leaderboards, executive dashboards, and performance tracking. Key takeaway: Databricks Metric Views make analytics simpler by allowing users to query trusted business metrics through the measure function. With Metric Views, you can easily perform simple aggregations by dimension, time-based filtering, total calculations without dimensions, percentage of the total analysis, and top K ranking and leaderboard reporting. The result is a consistent, governed, and reusable semantic layer that enables accurate business insights across the entire organization. Query once, trust everywhere. That's the power of Databricks Metric Views.
When should you use a Databricks metric view? A metric view is a Unity catalog object that centralizes business metric definitions using a semantic layer approach. Instead of defining the same metrics repeatedly across reports, dashboards, and analytics tools, metric views provide a single, governed definition that can be reused throughout the organization. Let's explore the key scenarios where metric views provide the most value. Standardize KPIs. The first use case is standardizing business KPIs. Organizations often track metrics such as revenue, customer count, conversion rate. Without a centralized definition, different teams may calculate these metrics differently, leading to inconsistent reporting. Metric views allow you to define these KPIs once and make them available to all teams. This creates a consistent and trusted source of business metrics across the enterprise. Handle non-additive metrics. Metric views are especially useful for non-additive metrics. These include calculations such as ratios, percentages, distinct counts. These types of measures cannot always be safely re-aggregated across different dimensions. For example, simply summing percentages or distinct customer counts can produce inaccurate results. Metric views preserve the correct business logic and ensure these complex calculations remain accurate regardless of how users query them. Enable flexible analysis. Another major advantage is flexible analysis. Metric views separate measures from dimensions through a semantic layer. This allows analysts to query the same metric across any dimension without redefining calculations. For example, the same revenue metric can be analyzed by region, product, customer, time period, or sales channel. The metric definition remains consistent while the analysis becomes more flexible. Power AI and BI integration. Metric views are also designed for seamless AI and BI integration. Metadata, such as display name, comment, synonyms, can be embedded directly into the metric view. This metadata helps power AI/BI dashboards, AI/BI Genie, and self-service analytics experiences. As a result, business users can discover and understand metrics more easily, while AI-powered tools can interpret business terminology more effectively. Key takeaway: metric views separate measure definitions from dimension groupings using a semantic layer. This enables standardized KPIs, accurate handling of non-additive metrics, flexible analysis across any dimension, and seamless AI and BI integration. The result is consistent, governed, and trusted business metrics that can be used across teams, dashboards, analytics platforms, and AI applications. With Databricks Metric Views, define business metrics once, analyze them anywhere, and trust the results everywhere.